Assalamualaikum and hi guys. Our group has chosen assignment topic which is application of differentiation. First, what is differentiation? In calculus, differentiation is one of important concepts apart from integration. It is also the action of computing a derivative and a method to find it. But wait, what is a derivative? Derivative is the rate of change of a function with respect to a variable. For example, the derivative of a function y equal to fx of a variable x is a measure of the rate at which the value y of the function changes with respect to the change of the variable x. It is called the derivative of x with respect to x. There are four basics of derivatives. First, algebraic function. Second, trigonometric function. Third, exponential function. And last, logarithmic function.
Those are some examples of rate of change. First, we have dv over dt. It is for rate of change for volume. Second, we have dA over dt. It is for rate of change for area. Third, we have dr over dt. It is for rate of change for radius. Fourth, we have dh over dt. It is for rate of change for height. Lastly, we have dl over dt, rate of change for length. Related rates are rates of change associated with two or more related quantities that are changing over time. For example, a spherical ball is being filled with air. Both the radius and the volume of the ball are increasing. Arguably, the rate of change in the volume, V, is related to the rate of change in the radius, R. In this case, dV over dt and dr over dt are related rates because V is related to R. There were few steps to solve the related rates. First, we have to determine what are the two variables. Second, detect an equation linked to them. Third, take d over dt from both sides. Fourth, connect all of the known values at the prompt from the question given. Fifth, clarify for the unknown rate.
A spherical balloon is being inflated at the rate of 8 cm³ per second. Determine the rate at which the radius of the balloon is changing when the radius is 10 cm.
So the question said that a spherical balloon is being inflated at the rate of 8 cm² per second. So it gives us the volume dV over dt equals to 8 cm² over second. And it also said that it wants us to determine the rate at which the radius of the balloon is changing. So it wants us to find the dr, the radius, over dt equal to what? And it also said that it also gives us radius equals to 10. So r equals to 10 cm. So first we need to write the equation first. So it's going to be dr over dt equal to dr over what times over dt. So in the blank, you see here we got dv over dt. So we write dv over dt, and also in the blank here we need to write dv. So now we already have dv over dt, and now we need to find the dr over dv. So the volume of the spherical balloon is 4 over 3 pi r squared. So we need to differentiate it, okay? So it's gotta be dv over dr equals to 4 over 3 pi r power of 2. So we can cancel the 3. So the answer is 4 pi r power of 2. So because of in the equation, it wants us to find the dr over dv. So we write like this: dr over dv equals to 1 over 4 pi r squared. So we now have dr over dv and dv over dt. So we just apply in the equation. So 1 over 4 pi r squared times with 8. So it's gonna be 8 equals to 4 pi r squared. Now we can cancel it. So 8 divided by 4 is gonna be 2. 4 divided by 4 is 1. So we get 2 over pi r power of 2. So now it gives us r equals to 10 cm. So when the r is the radius equals to 10, so we write back dr over dt equals to 2 over pi, and we insert the r is 10 power of 2. That equals to 2 over 10 power of 2 is 100 pi. So we can cancel it. So 2 divided by 2 is 1. 100 divided by 2 is 50. So the answer is 1 over 50 pi centimeter per second. So this is the final answer.
Application of differentiation can help us to determine the rates of change. A rate of change is a rate that describes how one quantity changes in relation to another quantity. We can connect real-life situations with basic solid figures such as cone, sphere, cube, cylinder, and hemisphere to find rates of change.